Hello class, welcome back. My name is Celine from 11 IPA. Today we're going to be discussing a topic we have previously learned in chemistry, which is acids and bases. Okay, let's get started on the basics of acids and bases, which is its definition. So, as we all know, acids and bases is measured by pH. pH is the abbreviation of power of hydrogen. So, this is an example of a pH scale. pH is a measure of how acidic or basic water is. The concept of pH was first introduced by the Danish chemist Søren Sørensen. The range goes from 0 to 14, with 7 being neutral. A pH of less than 7 indicates acidity, whereas a pH of greater than 7 indicates a base. pH is really a measure of the relative amount of free hydrogen and hydroxyl ions in the water. Water that has more free hydrogen ions is acidic, whereas water that has more free hydroxyl ions is basic. Okay, now let's move on to more definition and theories regarding acids and bases. So for our first definition or theory, it is created or founded by Svante Arrhenius. So he said that acid is a substance that produces hydrogen ion when dissolved in water, while base is a substance that produces hydroxide ion when dissolved in water. Okay, let's take a look on an example. So we have hydrofluoric acid. When it is dissolved in water, it creates hydrogen ion and chlorine ion. So because it produces hydrogen ion, hydrofluoric acid is considered an acid. Next, we have sodium hydroxide. When dissolved in water, it creates sodium ion and hydroxide ion. So because it produces hydroxide ion, it is considered a base. Okay. In the next theory, we have it is founded by Johannes Bronsted and Thomas Lowry. So their theory founded the Bronsted-Lowry bases and acids. So they said that acid is a substance that can donate proton, while base is a substance that can accept proton. So let's take a look on an example. So we see again hydrofluoric acid plus water yields fluorine ion plus hydronium. So I can assume that hydrofluoric acid is an acid. Why? Because as we can see here in the product, H2O will become H3O. That means it's going to be accepting a proton. So it's going to be accepting a proton or an H plus ion from hydrofluoric acid, and are going to be left with fluorine ion. And this also same goes reversibly. So when fluorine ion wants to become hydrofluoric acid, it needs to accept protons from hydronium, and when it accepts proton, fluorine ion is considered a base. So we can see here a pair of HF and fluorine ion. One has more hydrogen ion or a proton than the other. So this pair of substance is called the conjugate acid and base pair. This also happens with H2O and H3O. So H2O is going to be receiving the proton ion from hydrofluoric acid, becoming H3O. So when you receive, it becomes a base, and H3O is going to be giving proton to fluorine ion, so it becomes an acid. So these two are also conjugate acid and base pair. So fluorine ion is the conjugate base of hydrofluoric acid, while hydronium is the conjugate acid of water or H2O. Well, let's move on to the third theory or definition of acid and bases by Gilbert and Lewis. So he said that acid is a substance that accepts electron, while base is a substance that donates electron. So this is a Lewis structure of the chemical equation fluorine ion plus BF3 yields BF4 ion. So here we can see a fluorine ion has 2 electrons that it's willing to share with BF3. So, and to form a covalent bond. So, fluorine ion is donating electron to BF3. That means that fluorine ion is a Lewis base, while the BF3 is accepting electron from the fluorine, so it's called a Lewis acid. Okay, that's it for the definition. Let's move on to the properties of acids and bases. So I've given here a table on the properties of acids and bases as well as their differences. So acids taste sour while bases taste bitter. Acids do not feel slippery while bases does. Acids has a pH level lower than 7. Bases has a pH level higher than 7. Acids can release hydrogen ions in aqueous solution. Bases can release hydroxide ion when dissolved in water. Acids corrode metal while bases do not. Acids can react with metal while bases do not. And acids turn litmus paper into red while bases turn litmus paper into blue. Okay, let's move on to the chemical reaction involving acids and bases. So first we have reaction of acid with a reactive metal. The formula is metal plus acid yields salt plus hydrogen gas. So for the first example, we have magnesium plus sulfuric acid yields magnesium sulfate plus hydrogen gas. For the third example, we have copper plus H3N yields no reaction. So why is it no reaction? Well, we've previously learned about this table right here. This is the table of activity of metals and halogen, and copper is located here. So this is decreasing activity. So to review, this section of metals are able to react with water, steam, and acid. This section of metal are able to react with steam and acid. This section of metal is able to react with acid, and this is the non-reactive metal. Okay, let's head into our second reaction of acid with carbonate, which is the formula is carbonate plus acid yields salt plus water plus carbon dioxide. We have calcium carbonate plus hydrochloric acid yields calcium chloride plus water plus carbon dioxide. For the third reaction, we have reaction of acid with bicarbonates. So bicarbonate plus acid yields salt plus water plus carbon dioxide. So sodium bicarbonate plus hydrochloric acid yields sodium chloride plus water plus carbon dioxide. Okay, let's proceed with the fourth reaction. Reaction of acid with metallic oxide. So the formula is metallic oxide plus acid yields salt plus water. So zinc oxide plus sulfuric acid yields zinc sulfate plus water. For the fifth reaction, we have reaction of acid with metallic hydroxide. So the formula is metallic hydroxide plus acid yields salt. So zinc hydroxide plus nitric acid yields zinc nitrate plus water. For the sixth reaction, we have neutralization reaction. So it's acid plus base yields salt plus water. So for the example, we have sodium hydroxide plus hydrochloric acid yields sodium chloride plus H2O or water. For the seventh reaction, we have reaction of base with ammonium salt. So the formula is ammonium salt plus base yields salt plus water and ammonia gas. So for the ammonium salt, we have ammonium chloride, and then for the base we have calcium oxide. For the salt we have calcium chlorate. Water we have H2O, ammonia and ammonia gas. For the eighth reaction and the last reaction, we have reaction of base with the metal salt. So the formula is salt 1 plus base yields salt 2 plus metallic hydroxide. So we have iron sulfate plus sodium hydroxide yields sodium sulfate plus iron hydroxide. Okay, let's move on to the final subtopic, which is calculating pH and pOH. So pOH is the power of hydroxide, while pH is the power of hydrogen. pH is the measure of the acidity of a solution, while pOH is the measure of the basicity of a solution. A pOH plus pH of a solution equals to 14. pH equals to negative log the concentration of hydrogen ion. pOH equals to negative log the concentration of hydroxide ion. Okay? Let's head straight into our example questions. Okay, so for the first question, which of the following is the conjugate acid for sulfate ion? Okay, guys, pause and play when you're finished. Okay, let's answer together. Which of the following is the conjugate acid for sulfate ion? Let's write down sulfate ion first. So sulfate ion is SO4 -2, and then conjugate acid. So that means this is the base. Oops, sorry. This is the base. And we need to find the acid. So we know that the acid is the one that donates proton, and the base is the one accepting proton. I'm sorry. Accepting proton. Okay, so that means the acid one must have more proton. So we add H plus because H plus serves as the proton. So H SO4, and because -2, so we have 2 electrons plus one proton. So we are left with only 1. So -1 electron, so 1 electron. So this is the answer, guys. So the answer is C. Oh my god. So the answer is C. Okay, let me erase this first. Okay, let's head into our second question. A base accepts hydrogen ions. In which equation is the underlying substance acting as base? Okay, pause and play when you're finished, guys. Okay, let's review all the choices. So the first one, two hydrochloric acid plus calcium. So this calcium is going to be CaCl2, and it is not accepting hydrogen ion, so this is wrong. Next we have H2O plus CO2 and resulting to H2CO3. This is not accepting hydrogen ion because CO2 doesn't have hydrogen. And then we have N2 plus 3H yields to NH3. This is also not accepting hydrogen ion. They're combining together, forming a bond, so this is wrong. And next we have, and finally we have NH4 plus hydroxide ion and ammonia plus H2O. So we can see here that hydroxide ion is going to be H2O. That means it's going to be accepting electron from ammonium. That's going to be decreasing, taking out the hydrogen ion and giving it to hydroxide ion and becoming ammonia. So this is the answer. Okay, everyone got it right. Let's move on to the next, to number 3. Which substance in this chemical equation is considered base and acid? Okay, pause and play, guys. Okay, let's answer. So if you guys notice, this is an example of Lewis acid and base. So because it is having a covalent bond, so we can write it. Let's draw the Lewis structure first. So Ca, and then O. Ca plus Ca2, which is C, and then O and C. Okay, so as we can see here, calcium oxide, it has 2 electrons that it's willing to share with carbon dioxide. So what it means is that it's giving away electron. So the one donating electron is the base, while the one receiving electron is the acid. So to answer this question, base and acid, the base is CaO and the acid is CO2. Okay, let's erase this first. Okay, let's head into the next question. Which of the following is correctly arranged according to increasing acidity? Okay, so let's see. Okay, pause and play, guys. Okay. So let's see first. Let's find out the pOH and the pH of solution number 3 and pH of the solution number 4. So we know that pH plus pOH equals to 14. That means that pH equals to 14 minus pOH. So the pH of solution number 3 is 14 minus 6.06, which is 7.94. And then pH number 4 is 14 minus 12.9, which is 1.1. Okay, now that we know all the pH, let's arrange the pH based on increasing acidity. So we know that this is 7 is neutral, and the lower it gets, the more acidic it becomes. So to arrange it according to increasing acidity, so from highest pH level to lowest pH level. So for the first one, the highest one is number 2, and then the second highest one is number 3. The third highest one is number 1, and finally we have number 4. So the correctly arranged pH level is 2, 3, 1, 4. Okay. This is the answer, guys. Let me erase this. Okay, let's head into our next question. The pOH of a solution is 6.5. What is its pH? Okay, so this is using the same formula as number 4. Pause and play, guys. Okay, let's answer together. As we know already, pH plus pOH equals to 14. So pH equals to 14 minus pOH. So the pH is 14 minus 6.05. Which is 7.95. Okay, so this is the answer. And that is actually it for my presentation. Thank you so much for listening. I hope the knowledge I have given today on the basics of acids and bases are useful. Stay safe and see you next time. Bye bye.